Good afternoon, everyone. Nice to see you again. I did give a lecture yesterday morning for a short while, so we're going to continue more on this. I've been noticing all the lectures of all the other speakers. I learn from every speaker's lectures all the time. I believe we have to learn until the day we die, and technology goes on and on and on. So the same things go for the stem cells. Stem cells evolve all the time too, you have to understand. Just like our iPhone or Samsung phone. Each time they change a new phone, you also have to you have to use the new phone because technology is different, right? So the same things go for the stem cells. Now, what do you mean by organ rejuvenation? When we say organ rejuvenation, we mean to say that in your body, you have 220 organs and tissue. And there are there's around 400 different types of cells, all different organs. The brain itself, as one organ, has 67 different types of brain cells. And there are 56 different lobes in the brain. So you're thinking of treating Parkinson's patient, you probably have to think which part of the brain you have to treat. So that you have to look at the MRI. The same will go for Parkinson's, the same will go for autism. The same will go for Down syndrome. The same will go for Alzheimer's. So we are talking about very specific way where we talk about precision medicine here to treat Down syndrome, to treat the patients. That means I believe in organ tissue specific cells. We can do the stem cells. We can do the peptides. We can do the exosomes, and we can do the cells. Now you have to understand there's a lot of difference between cells and stem cells. Okay, we'll explain later from here. Now, just some background on this. I spent 35 years of my life together with my wife solely in cell research and biological regenerative medicine. Because in biological medicine, which is a European way of treating, especially with the Swiss and the German, we always believe that the body can heal by itself to a certain extent. So we are finding and treating the root of the symptoms. We will not just treat the symptoms here. We always believe there's a way to find it and treat it well. It's like you have a sleeping disorder. We can fine-tune the pituitary and give the pineal gland so that melatonin can be released more. We are not going to rely on external hormones or other melatonin externally. The same thing goes for hormonal modulation. BHRT and HRT will only adopt at the last stage. If we can fine-tune the pituitary gland to send a message down to the adrenal cortex and down to the gonads, then obviously we can fine-tune the hormones because the organs, the gonads, the testes, also ovary releasing the hormones is just like a printer. It needs to be activated. The CPU is the pituitary gland, your master gland. Now, after all these years of going through with the research, we start with manufacturing. But manufacturing requires sales. And the funny thing about our company all along is we don't have a sales manager until today. We don't have a sales and marketing team at all. So how do we sell our products? It's totally by free education to all the physicians across the world. Free. The same things go for our end users. We provide them free education. We totally believe that we must educate the physicians so that they can create the awareness to the clients. Now, 10 years ago, we started to acquire hospitals and clinics all over the world. We started with the first one called Paracelsus Clinic, Luschmüller. That was one of the first regenerative hospitals. It's a popular one. And 2 years ago, I sold it to a big Chinese conglomerate. And I acquired a rival, Villa Medical in Germany, because the laws in Switzerland changed all of a sudden on cell therapy a few years ago. And recently, they reversed back the law because of a court order. All right. So laws keep changing with cell therapy, and the same things go for stem cells. We have to understand that. So the laws, example, in US now, I understand that stem cells is only for research. You cannot do it legally. So you have to go out of USA to do that. But again, in different parts of the world, for example, in Switzerland, you cannot even do autologous stem cells. You can't. So let alone the other types of stem cells. Same for Germany. You need special license. You must have GMP facilities and certification. That is very important. Now, surprisingly, cell therapy to a certain extent is allowed in Switzerland. And same for the Germans to a certain extent. The laws are changing all the time with pressure from the pharmaceutical industry, but again, there are always exceptions. Okay. Now, these are the number of clinics we have at this moment. We have 21 clinics and hospitals all over the world, from Switzerland to Germany to many parts of Asia. It's high time you're going to come to the US and provide some clinic and set up some clinic to provide special service to the American clients. Because we have a lot of American clients who will travel all the way to Germany or Switzerland for treatments. And we have found out some good partners that we are going to start in Tijuana. We will probably start in Arizona. We will probably start in Bahamas. These are some of the target areas we have to do because we cannot do stem cells legally in US soil. But we can do in certain areas, which is outside US. And we believe that we must do it the GMP way. It must be certified the GMP way. It's very important that because the first thing in medicine is safety too. First, do no harm. Now, coming back to this, you have to understand in the human body, you have it's always at the cellular level you have to repair. Why? Because all the disease is in the system. The system fail is because of diseases coming in because due to the malfunction of the system. And what is inside the system? The organs and tissues. Your organs and tissue age as time goes. And what about the cells and the stem cells inside your organ? They age too. So everything ages. You are aging in a way. Of course, there's a way to do with the reversals, okay? So we must repair at the cellular level. You can do all kinds of treatments. With all the treatments, you have to complement. But at the end of the day, you must repair at the cellular level. So you still need the cells. In this case, whether it's the cells or the peptides or the stem cells, obviously the stem cells will be better. Now, again, for the general layman, they always say, stem cells, yeah. Stem cells can turn into all kinds of cells. Wonderful. They can turn into everything. Is it true or false? It depends. Okay, I would say true to a certain extent and false to a certain extent. So this is where you have to understand what type of stem cells can turn and what type of stem cells don't turn. Okay, and then you have the question now of, oh, sorry, I pressed this wrongly. Now, you have the word totipotent, you have pluripotent, you have the word multipotent, and you have the word unipotent. Okay, now most of the time you've been hearing a lot about pluripotent, that is the embryonic stage. Okay, you heard a lot about embryonic stem cells. The problem with embryonic stem cells is embryonic stem cells can turn into all kinds of cells because it's pluripotent. But at the same time, it can also turn into cancer cells. So for these reasons, we shouldn't use embryonic stem cells. And again, for ethical reasons, most countries of the world would not allow that. Of course, there are still some illegal countries. Some countries, underdeveloped countries, they will illegally do embryonic stem cells. It happens also in China in certain areas, even in Europe, some underdeveloped countries. Okay? Now, what about multipotent? What do you mean by multipotent? That means these cells can turn into certain amounts of cells. And I remember my colleague, Dr. Dimitri, yesterday was mentioning. He said they can turn into 7 different types of cells. They're all tissue-based. They're not organ-based. Please remember that, okay? So you expect a mesenchymal cells, which is multipotent, to turn into a heart cells or liver cells or brain cells? The answer is no. But it may, the word is may, it may turn into the chondroblast or osteoblast to a certain extent. That's why sometimes you use it for the knee, it works. But sometimes it don't work. So there's something you have to understand. Now, what about unipotent? Something may be new to some of the American people here because they are not so exposed to progenitor or precursor stem cells. But it's nothing new in Europe. It's been there for almost, in Germany, 150 years. They've been using it for 150 years. Even the old physicians, Swiss physicians in the 16th century, they've been using organ therapy. We call it organotherapy. That means you use A for A. We believe that in the body, there must be a liver for a liver, a heart for a heart. We are going into very specific here. Now, this is something which we compile to make it clearer for the layman to understand. Because there are so many types of stem cells, and each time everyone will be asking, will this stem cell work? Will this stem cell cause cancer? Will this stem cell this? It's good for you to take a picture of this, and this will be in your library. Now is a high time you can understand the characteristics of each different types of stem cells. They have different types and different characters. Okay, so again here you can notice that we are talking about bone marrow, and if you talk about bone marrow here, or talk about umbilical cord blood, what do you find in umbilical cord blood? There will be the mesenchymal cells and a small amount of hematopoietic cells for blood disorder. Okay, so if you are thinking of umbilical cord to turn into a neuron, or turn into a medulla alba, or turn into an ovary, or a hepatocyte, no, the answer is no. We have not reached that stage yet. Even with the latest technology of iPSC, induced pluripotent stem cells, which you have noticed here, okay, sorry. You know, this is a Nobel Prize winner, Japan. The Japanese learned very much from the Europeans, and then they started with a lot of mesenchymal cells. They won a few Nobel Prize. Even for iPSC, everyone is using the magic word. And the last speaker was mentioning about that. You will turn, into the embryonic stage. We are only talking about embryonic stage. You was from a precursor stage, you went back to the embryonic stage. But now you have to understand, you are going to return back to the progenitor stage. So my question is, why do you have to go and turn from progenitor to embryonic and then return back to the progenitor? Why don't we just go it straight? Take the precursor ones and give the precursor. If you need the hepatocyte for your liver problem, give the hepatocyte. If you need the retina cells for your eye, give the retina cells. If you're going to treat CKD, give the epithelial cells and the renal cells. This is how we go with technology. And these are organ tissue specific. And the same go for the dogs and cats, which I always use the word kiddies, because I have 10 puppies in my house. I'm always the midwife delivering the kids, okay? And next. Please to understand, you're born with 37.2 trillions of life cells in your body. And out of these 37.2 trillions of life cells, there's only one stem cells out of 10,000 life cells. So don't expect you have a lot of stem cells. And if you were to look at the chart, at the end of when you're 60 years old, you only have 1 out of 800,000. That means to say you're aging at a very fast speed, okay? The rates are different. Now, let's go further from here. Another chart here. You can say that by the age of 18, you only have 40% left of the active stem cell in your body. And by the age of 60, you only have around 5% left of your stem cells. So don't you think you need some form of replacement here? Obviously, you do. You need some form of replacement to do the stimulation, but you also need the repair. And the repair comes with the regenerations. This is where you need to go with organ-specific tissue stem cells, or cells, or peptides. Now, next, the question will be asked, will the exosomes, or the peptides, or the cells, or the stem cells, which one will work better? Now, in my general experience of having 35 years in the lab, I will always say the stem cell will work the best. Because the stem cell comprises the whole thing, including the nucleus, the organelles, and every stem cells and live cells has exosomes. Because that is the secretions or the secretons of the cells. As long as the cells, you have the exosomes. Now, exosomes is found all over our body, including in our urine and in our blood. So you have the bonus now. You give the stem cells, you have the exosomes along the way. Okay? Now, what about the peptides? The peptides are just a components of the cells, a small part of the cells. So if you expect the peptides to go and work the function of the stem cells, I don't think so, because we manufacture the peptides, the exosomes and the stem cells. When we started to introduce exosomes in 2010, in the A4M conference in Las Vegas, and we talked about stem cells, it was a bit raw in those stages because it was too early, maybe. Okay? Now, I would say there's a lot of technology going on in Europe and even with the Japanese. We work very closely with the Germans in Heidelberg University, one of the top universities for stem cells and immunology. We work very closely with the Japanese, and we work closely recently with the Chinese too. So it's high time we have to work with American scientists here on stem cell research. We do all kinds of cells. We do the human, we do the autologous, we do the autografts, we do the xenografts. As far as we are concerned, the important thing is deliver the results to the patient. If you don't deliver the result to patients, it's no point because you will never sustain or build your reputation. So we will never think that we should treat a patient if we are not confident to treat them. And you're going to harm the patient. That is not what we want. Okay? So I did mention about peptides. Now, you're so familiar with peptides all the while. You're thinking peptides are certain types of things. You're talking about peptides which are synthetic. But there are also peptides which are organ tissue specific. Now, remember I told you 220 organs. and tissue. So there are around 400 over different types of cells from 220 organs. So every peptides and cells and stem cells, there is a possibility to get it from the kidney, or there's a possibility to give a retina or to give a liver. So if I can give a liver peptides, why must I give a synthetic peptides, which is a non-liver for my liver condition? If I have an eye problem, I'd rather give you an eye peptide. It can be done. It's just that it's mammalian-based, animal-based, okay? So that's another thing you have to understand. While dealing with all the cells, okay, and understanding with the stem cells, doing all the research, we found out something here. After learning from the Soviets in 1985 too, apart from the Germans and the Swiss and the Austrians, we found out something here, okay? In the fetal stage, cells of all animals, including human, sitting on top of the animal kingdom. Man is an animal too. They are alike. We are talking about fetal cells, which are 0 age. That is the best cells because it's 0 age. It's not out from the mother yet. There is very low antigenicity in the fetal stage. And with our technology in the culturing process of turning the antigen lying on the surface of the cells, the membrane of the cells, to go inside the cells, when you inject the stem cells into the patient deep intramuscular, even on a 6-week-old baby, there is 0 immunorejection. We have never given immunosuppressive drugs to anyone in our treatments of patients. We have done thousands of patients on autism and on all different types of disorder, including Parkinson's patients. So what is so unique about the fetal stage? Because in the fetal stage, it's different when the baby is out. When the baby is out, the baby will suck the milk of the mother. When it sucks the milk of the mother and fill up the stomach, that's where bacteria set in and virus set in. So that is the difference why you must use the fetal stage. So the Soviets in the 80s were using, with the authorization from the governments, they were using human fetuses. Those days, when I was a student learning from them. But you have to understand, those were the times you can kill a fetus, not today's. You can't kill another human being today or a fetus for another person. It's impossible. And in the technology you're doing the stem cells, I have to say we are using 60 fetuses for 1 5 ml of cells. So there's a lot of things here you have to understand. You cannot be killing 60 fetuses for one patient here. So that's why we have to move to animals to a certain extent. Now, animals is nothing unique, someone will say, why animals? But my question is, if you cannot get it from human, you always have to get it from animals. There's no other choice. As long as you're getting the right and the safest animal. And we'll explain further on that in the later lectures. Now, again, you have to understand, your organs and tissue are going down. Your lungs start to age at 20. Your brain start to age at 22. But your frontal lobe, one of the brain part, will only fully develop at the age of 26. So you are already aging while you're still developing with your brain. Now, what about the fertility of a male and female? You start to age very fast too. At 35, the fertility of a male is going down. Okay? Your hair starts to lose around 30. The texture of your hair tells about your health to a certain extent of all the minerals and all the heavy metals. Okay? Now, again, what about the liver? The liver is the best organ. It only ages at 70. But most of the other organs, they start to age around 30 and 40. So it's high time we have to take care of ourselves. Now, how are we going to do with all this now? This is a compiled table where you can use it and refer that why certain organs age so fast. Okay, and that certain organs you have to prevent. It's like for a diabetic patient, you have a problem with the pancreas. Okay, so with the pancreas, it will lead to a problem with the liver. It will lead to a problem with the stomach, intestinal. So you have to treat every organ to a certain extent. And the end stage for a diabetic patient will be a kidney transplant. And he will also have eye problem. So you have to take care of his eye, you have to take care of his kidney. Because the kidney cells normally don't regenerate. All along, we are born with fixed kidney cells. But recently, we did some publications that we can even regenerate the kidney to a certain extent. So this is what we are talking about, organ rejuvenations. What I'm trying to tell you is, we want an A for an A B for a B, a C for a C, a D for a D. We are not going to use a to treat the A, B, C, D, E, F, G. That's not the way we want it. We want very precise medicine here. You are going to throw the dart right at the dartboard and hit it at the bullseye each time you throw the dart. Remember the lecture by Dr. D yesterday. He was saying that you use a rifle and a machine gun. You use a rifle and a shotgun. The shotgun right at the bullseye. The rifle you shoot hit all over the board. So we want the one which is right at the bullseye, 50 points. Okay. Now, this principle has been on in the 19th century of similia similibus curanto. It means like tricks like. So this is what we are trying to say. You must have the same stuff for the same thing. It's no point to give mesenchymal cells for a brain disorder, or for an eye disorder, or for an ovary, or for a lung. If I can give a lung for a lung, a brain for a brain, and I go into very specific now, you need the substantia nigra. We give you the substantia nigra. So that is important. Next, for your understanding of animals derived, there are more than 10,000 animal-derived products approved by FDA. You are using insulin all the time. They are coming from pigs and cows. There's so many other drugs, including cerebral lysines, coming from pig's brain, approved in Europe for more than 40 years. You can get it in any pharmacy of the world, but in USA, no one is allowed to buy it. Of course, there are physicians who go all the way to Europe to buy it for the treatment of Alzheimer's. And it doesn't cost a lot of money. Okay? Now, the next thing I'd like to show is that in the case of animal and human, there's a lot of similarity from the structure you can see here. This is in the fetus area. When you compare the fetal area, you will see that they're so alike. That is why there is no rejection in the cell level. We are talking about cell or the organs. There's zero rejection. The rejection only comes in the organ between animal and human. But even with human and human, you will also have the rejection. So that is the point I'm trying to say. We are implanting cells. We are not implanting organs. We don't need organ transplantation if we can repair at the cellular level at the early stage. That is very important. Okay? Now, Japan, one of the top countries in stem cell research. 35 years ago, they learned up immunology from the Germans very much. They sent all the top doctors to Germany to learn about cancer immunology. But after that, they learned very fast. You know, after Japan, the Japanese, after World War II, they went into industrialization. They've been doing a lot of research. The last 10, 20 years, they've been winning a lot of Nobel Prize in stem cell research, or mostly on mesenchymal stem cell human. And all of a sudden, quietly in 2014, they started a lot of research on animal. And the reason is because they are trying to treat diabetes, and they cannot get it from the human. So they have to get it from the animals. In the case of the Japanese, they've been using all the research using pigs. Okay? While on our side, we do the human, you do the animal, we are using the sheep and the rabbits. The sheep has been widely used for 150 years in Switzerland and Germany. It's nothing new. But the new technology was the rabbit, and you'll be surprised. The rabbits is the only animal, you can ask any vet of the world, that they are retrovirus-free. They don't spread disease to another species. You have 1,000 white rabbits, and one of them is sick, and you mix it with another 1,000 white rabbits, they look similar, but of type B. The 1,000 in type B, none of them will be dead. But the 3 weeks to 4 weeks in type A, all of them will be dead. So you see the difference here. You can mix around and they don't even spread the disease. They are retrovirus-free. Any vet can tell you that, okay? So you can see from this chart itself, they're telling you a lot of things. Things are moving out on the other part of the world at a very fast speed, okay? Now, all these are things. Now, the question thing is you need to know what type of stem cells you are given. You also need to know how potent they are. And are they really stem cells? Someone gave you something and say, oh, these are stem cells. You need proof. You must have the lab report. It must come from a GMP lab with all the verification, validation, and how safe are they. All this must be with the lab report. You must see the lab yourself. You must have some validation here. Otherwise, you cannot believe it. I can give you something and say these are stem cells. Now, there's a lot of difference between cell and stem cells too. So if I take the cells from you and I give it back to you and say I increase the cell count, now, if I increase the temperature by even 1 degree, your cell count will increase. Now we are not talking about the cell count only. We are talking about the quality of the cells. Where are the cells coming? If I'm 59 years old, my cells is always 59 or older. Biologically, I may be older. So why must I have a 59-year-old cells if I can get it from my grandchildren? Okay, of course, my grandchildren will be better. You heard of young plasma. Now, plasma is only about the plasma. Now we are talking about the cells. But if I use the fetal cells, obviously it's even better. Because if I get from my grandchildren, I can only get the mesenchymal cells from my grandchildren. I cannot get the retina cells from my grandchildren. I cannot get the eye cells from my grandchildren. So this is where it doesn't work that way too good. But along with the autologous, you can blend with the animal peptides. Okay, I use the autologous, I can blend with the animal peptides, then I have 2 in 1. It can be done easily. This is what the other doctors are doing in different parts of the world. Okay. Now, of course, we do everything to check everything. Time is running out for me. Now, the source of the animals and human materials are very important. Okay? If you are given some human source, you must know the donor. You must have knowledge of the donor. You must have some validations. Because it's not just a collection from the gynae office and given to you and you inject on your body. You don't even know who is the donor. It's time to hold the labs who do all this to be responsible. I believe in accountability very much because we have to believe on the safety side. The same goes for the animals. In the case of the animals, we are talking about SPF animals. Now, what is SPF animals? SPF animals are even safer than human. They're coming from USA. We call it specific pathogen-free. There's 0 virus in the animals. And another name for SPF will be virus-free antigen. This is the future of medicine. 5 years ago, we have started with all this. So whatever material coming from us, they'll be specific pathogen-free. And they come from USA. They're all laboratories animals. They're shipped from US soil with the approval of the FDA. This is where medicine has to go to the next level. Okay. Now, of course, you also need other certifications. Safety, view the plant, look at the plant, ask questions. Do we have certifications? Do you have verification? Again, what I'm trying to show you here is 1 cup of coffee can be 8,000 cups of coffee if we dilute them. But it can also be 6 cups into 1. So a matter of dilutions will make a lot of difference for the manufacturer. I can give you a very diluted thing and make an IV on you. But I can also make it very concentrated and inject IM on you. So there's a lot of difference here to ask. Okay? Now, on the treatments of protocols, let's look at the organs. In the brain, like I say, you have 67 different types of cells. You have to look at which part of the brain. You have to give the different organs of the brain. But when you're treating the patient, you have to understand it's not just a brain problem. He probably is aging. So he probably have an aging liver too. He probably is a drinker. He also have a liver and some other problem. He's a diabetic too. So you have to treat everything. Don't just treat the brain. Okay, you have to treat the whole body and look at the whole anatomy. Obviously, from here, we must have the blood test reports and the pathological test and the hormonal test. Okay, and they have to understand certain things. Okay, now I just go over. My way of looking at things is not treating with the cells alone or the stem cells. Before that, you must do a proper diagnosis. You must have the detoxification, and then you have the repair, and then only you rejuvenate with the cells. That is the right way to do it. I sincerely think stem cell and cell therapy need more attention and more awareness. We have to come up with the education to come with this. We always believe that we must have case studies and publications and peer-reviewed journals. That's what we have been doing for the last 2 years, 20 publications on cell therapies and books to cover what we are trying to promote. Now, we endorse all kinds of cell therapy. It doesn't matter if it's human or animal, as long as it works. Coming back to accreditation and certification is very important too. We are accredited with 20 over certifications across the world. And that's a good news. My question is now, shouldn't us, the physicians, be more open-minded? If we can do something like this for the Down syndrome children, okay, like this girl at 1.5 years old, this boy at 9.5 years old, within 1 year you can see the face change. Your face is your brain. So you can increase the IQ and the intelligence of a person by giving the right brain cells. So if someone would ask me the question, can you make my child more intelligent? Yes, I will give you the frontal lobe. That is, the younger the better. Okay? Because the brain is, to a certain extent, will be fully developed by the age, like I say, around 20 and 26 to a certain extent. But some parts are already developed at the age of 5 years old. So there are many other conventional medicines which you cannot find a treatment, but they are solutions with certain specific cell therapy. Thank you so much.